What's up guys, and welcome back to a new video where we'll be diving into a new crash course called Git in the CLI. Quick pause. Do you want to support the channel and want me to continue on creating content? Well, you can support the channel on Patreon right now, where you get benefits as a private Discord group where you can share your coding issues and other developers will help you out. If you are interested to join, the link can be found in the description down below. Before we directly dive into Git, I do want to take a moment to talk about what Git is and mostly what the usage of Git is for not only web development but development in general. Git has been created in 2005 by the developer of the Linus kernel named Linus Torvalds. At the beginning, Git was mainly used for the development of the Linux kernel itself. Git is a DevOps tool, which is mainly used for source code management. It is free and open source for version control, and we will dive into version control in a moment. The biggest advantage and the reason why developers use Git is the fact that it basically allows multiple developers to work together on a non-linear development. Now, what is version control? The name version control pretty much says what it does. It is used to control different versions of a coding project. With the usage of version control, all changes to a project or a specific file obviously will be tracked. Think about adding new files, editing files, or even deleting new files. The power of version control comes in handy when working within teams. It allows multiple developers to contribute to a project, and all changes will be tracked with a contributor attached to it. Now let's all be honest to each other. We all have once worked in a project where we kept making copies of our project, where we changed the folder name and tried to manage our different versions. I will go first. I did it too. I remember that I copied a folder named project_final. Then I made a copy of that project with _copy again. Then I needed a new version, so I named it _final_reviewed. Finally, I had my final_v1 for version 1. So trust me, you're not the only one. We all have been there. Using this method will get out of hand very fast, especially when dealing with deadlines and you forget in which folder a certain functionality belongs. Now, why Git? Even though we talked about version controls, we haven't really dived into the usage and power of Git. Git solves a couple important problems. It allows you to go back and forth between different versions, so you don't need to make a copy of your project by right-clicking on it, copying or zipping it. This will all be done with Git through version control. It also allows you to review differences between versions, which is incredible because this will show you exactly what has been changed within a specific file. It allows you to change the history of a file, and it allows you to review the changes from other developers and even leave feedback for them. With the usage of Git, a lot of new terms come into play. And I do want to take a moment to talk about the most important terms that we will be using during this crash course. It obviously doesn't make sense to cover them right now, because we will be doing that later during this course as well. But Git uses a lot of terms that you haven't heard before, which can be overwhelming. So therefore, I do want to cover the most important ones right now, starting with the repository. A repository is basically the storage where all your projects and project changes will be saved. Then we have branches. And a branch is the main feature of code reviews. A branch is simply your own independent copy of the project at a certain time. With branches, snapshots are pretty important, which is a Git term which can be replaced with revision. With Git, you are tracking the entire workspace of a project folder with snapshots. Then we have commits, and a commit is a snapshot of the project's current stage changes. Once a snapshot has been made, information about the author of the content and the person who makes the commit will be saved into the repository. Then we have the term master, which is the primary branch of all repositories. All commits and accepted changes should be in the master branch. You should also create new branches from the master branch. At the moment, I'm located on the official website of GitHub and we won't be using this a lot. Before we get into using Git, we do need to have a GitHub account to perform actions with Git. So I've already got an account, create yours, and I'll see you back on the dashboard overview of Git. When it comes to installing Git on your local machine, you could use different options. Now at the moment, we're located on the dashboard of GitHub, but this is not the command line interface, which we will be using during this course. Now we do need to make sure that we install Git CLI on our local machine. And this can be done by opening a new tab and navigating to git-scm.com. On the homepage, you'll see a button right here called Downloads. So let's click on it. Git gives you an option to download it for your operating system. It's supporting Windows, Mac, and Linux. The installation process will be pretty similar on all operating systems. I'm currently on a Mac, so I need to choose macOS. Right here, it's telling us that we can download it through different platforms. What we will be doing is copying the brew install command right here, navigating to the CLI, and paste it right here. If we hit enter, it will take a couple minutes, so pause the video and I'll see you back once it's done. Even though Git is installed right now, we do need to make sure that we set it up correctly. Keep in mind that whenever you set up Git, you will most likely have to do it once, since the setup is stored in an external global file, meaning that all projects will share the same configurations. Therefore, we got to make sure that we tell Git what username and user email is going to be used. So we need to perform a command right here. And the command that we're going to perform will make some changes inside our global settings, meaning that it doesn't matter where you are located inside your CLI. So we're going to perform the git command, and we're going to set a new configuration, so config. Then we're going to say that we're going to set the global configuration by adding a _ global. Right here, we're basically telling Git that we're going to set this command up for all future Git repositories. Then we're going to set the user.name, where we do have to pass in an argument with the user name as a string. So let's add double quotes and go right inside of it. Now let's add a name of code with Dari. Keep in mind that the name needs to be equal to the account that you use to log in to GitHub. The same command pretty much needs to be performed again because we do need to set the most important one, which obviously is the email that you have used to register on your GitHub account. So let's say git config _ global. We're going to set the user.email, which is equal to the email that I just added on the GitHub page. Git gives you an option to see the username and user email that you have set. This allows you to check whether the credentials are correct or not. We simply have to perform the git config user.name. Right here, you'll see that the username is code with Dari. And then we can set the git config user.email, where you see that the user email is equal to the email that we added right above. Git allows you to find the files of your Git configuration file right inside of your home folder. At the moment, I'm located inside my home folder, so let's perform an ls-a. It is a hidden file, so let's navigate up to the files and folders starting with a period, and let's search for git config right here. You'll find all configuration files. We're not going to open it, but if you do need to add some changes, it will be right here. Next to the global configuration file, there's one more file in the same location named bash_history. So let's scroll up to the B. Right here, we have bash_history. All commands that you have performed related to Git are stored right here. The last setup that I want to show you is changing the editor you use for Git. By default, Git uses the default text editor that will be used when you need to type a message. This probably makes no sense right now, but it will do later on. Whenever you want to change your default text editor, we have to perform a command with the same structure as the Git name and email. So let's say git config _ global, where we're going to edit the core.editor, and then we need to add a editor name. Well, in our case, let's just say Emacs. Right here, we have changed our default editor to Emacs. We've already touched on repositories in the Git terms chapter, but the most used term when it comes to Git is repositories. A repository is basically the storage where all your projects and project changes will be saved. Before you start any project, you first got to set up a repository for it. This can be done through the GitHub page or through the CLI. And it's very easy to set it up through the CLI. At the moment, I'm located in my home directory. But right on my desktop, I have a folder called Workspace where I store my YouTube related projects. So let's change directories to our desktop and my Workspace folder. If we hit enter, you'll see that our directory has been changed to our Workspace directory. Then inside our Workspace, we first got to make sure that we create a directory where we would like to store our new project. So let's create a new project by writing down mkdir, which will make a new directory for us called git-in-cli. Now a new repository needs to be created inside our newly created directory. So let's change directories into our Git in CLI directory. If we perform an ls-a command right here to list all normal and hidden files, you'll see that our folder is completely empty. But now that we have a directory, we should create a new Git repository right inside of it, which is very easy, because the only command we need to perform is git init, which stands for git initialize. Throughout this course, and even in the future when working with Git, you'll see that it uses tons of shortcuts to make the process a lot easier. Let's hit enter. Alright, it returned a message saying that an empty Git repository has been created inside the directory where we are located. When Git initializes a new project, a new directory will be created called Git. If we perform ls right here, you'll see that no new directory has been created and the output is empty. That's because Git initializes a new directory with a period in front of it, meaning that the directory or file is hidden. So whenever we perform an ls-a command to list all hidden files and directories as well, you'll see right here that we have a .git directory. Now this directory is created when we perform the git initialize command, and it contains all information required for version control. If we change our directory into the .git directory, hit enter, perform an ls-a, you'll see a list of new files and directories right here. Now let's go over them one by one. The blue ones, so branches, hooks, info, objects, and refs, are directories, while the white ones, so head, config, and description, represent files. So let's cover them real quick. It won't make sense right now since we're going to use some Git terminology, but it will make sense if you finish this tutorial and come back later on. The first file is called head, and this is the current branch we're working on. Then we have the branches directory, which shows all branches. Then we have the config file, which is basically the configuration options. The description file, which is basically the description of the Git repository. We have the hooks directory, which has example scripts. Info, which excludes files for ignored patterns. The objects has all objects. And the refs is the pointers to commit objects. Now let's move back one directory by saying cd ... and let's perform a clear. Alright, everything outside of the .git directory, so basically everything within our Git in CLI directory right here, is called the working directory, where all files you are going to use when developing code will be stored. A general rule of thumb is to store all more recent versions inside the version directory. You are completely free to edit files and folders inside your working directory, but keep in mind that you shouldn't modify any files inside the .git directory. Once you make changes inside your working directory, there's an option where you can check the status of the working directory with the git status command. So if we perform the git status command right now, you'll see that we're currently working on the branch called master, which is the default branch name for a working directory that's new. There are also no files to commit. And whenever you want to perform this command, you do need to have a file inside your working directory that we could save to Git. So let's create a new file. Let's say nano index.html, where a new file will be created called index.html, but we do need to add content inside of it. So let's say this is my first Git file. If we perform a Control X, you'll see that it will save it. So let's say Y and hit enter. Alright. Git should detect that the working directory has been changed since we created a new file. So let's perform the git status command one more time and see what has been changed inside our working directory. Right here, you'll see that we're still on the branch called master, and that's alright because we haven't changed our branch. There are no commits, but we do have one untracked file right here. And untracked files are basically all new or modified files and directories inside your working directory. Next to untracked files, we obviously have something which is called tracked files. These files are the ones that have been handled by Git, so they have been version controlled. All untracked files you'll see in the Git status need to be stored inside the staging area, where a snapshot will be taken. A snapshot is a Git term which is a replacement of revision. In other version control systems, changes to individual files are tracked and referred to as revisions. But with Git, you are going to track the entire workspace, so they use the term snapshot. Before you take a snapshot of the project, you have to select which changed files and directories needs to be snapshotted. This can be newly files, deleted files, or edited files. Whenever you want to add a file to the staging area, you need to perform the git add command, followed with the name of the file. In our case, we're going to add the index.html file. If we hit enter, you'll see that the background color of our master branch changes from green to orange. Green means that the branch we're on right now is ahead of its remote. At the moment, it's orange, meaning that the branch is either ahead or behind of its remote. Now, if we add two more files right here, so let's say nano about.html, let's say this is my about page, save it. And let's also add a style.css file where we just add an X, save it. The reason why I just created two files is to show you that you could also add multiple files together in one line. If we perform the same command again, so let's say git add, followed with the about.html file, there's no need to hit enter and perform the same line with the style.css file, since we simply can add it right after the about.html file. If we hit enter, perform the git status command, and right here you'll see that it has added 3 new files under the stage to be committed section, where it says new file right in front of the about.html file, index.html file, and the styles.css file. These 3 files have been added to the staging area. As you could see, it also allows you to perform the git rm cached command, which will remove the cached files to the unstaged area. So let's copy paste it. Then we need to add a file name. Keep in mind that you do need to add the -- cached option when you want to unstage a file. If you don't add it, you might lose the entire file. So let's say that we want to unstage the index.html file. Let's perform a clear, perform the git status command. And right here, you'll see that the index.html file has been added under the untracked files section. But the about.html file and the style.css file are added inside the tracked files section. Now, before we continue on with working with commits, I do need to show you one more way on how you could add and remove files, which is definitely not the preferred way, but I'll explain it to you why in a second. Now let's hit the arrow up to the git rm cached. And let's untrack the about.html file and the style.css file. If we perform the git status command right here, you'll see that we once again have 3 untracked files. Now let's add them to the staging area one more time by saying git add, but instead of specifying the file name, we're going to add a period. What the period does is adding every single untracked file inside the current working directory. Right now, we're only working with 3 files, which is alright. But if you are working with larger projects and frameworks, you will add all generated files, backups, configuration files, and so on, which are files you don't necessarily want to add to Git. Therefore, I always recommend adding specific file names or directory names, rather than adding everything like we did right here. If we perform the git status command, you'll see that all untracked files in the working directory have been added to the staging area. Now that we have added files into our staging area, it's time to move on and talk about committing, since it is telling us that changes needs to be committed. Once you make a commit, a snapshot of the project's current stage will be made. Git will never change a commit unless you ask them to do so. Once the snapshot's made, information about the author of the content and the person who made the commit will be saved inside of the repository. In most cases, the author and the person who makes the commit are the same, unless the person that commits took the change set from a team member, which isn't something we will be doing in this course, but it is something that I had to get out. Now let's make a snapshot from the current project, where we added 3 new files. Git offers 2 ways on how you could commit your tracked files. The first method is by performing the git commit command, and I'll show you the second method in a couple minutes. Right here, our editor popped up again, saying that we should enter the commit message for our changes. Lines with a hashtag will be ignored and an empty message aborts the commit. So all lines right here with a hashtag will be hidden, and right here, where the line starts, we do need to add a message. So let's say that we will name our message initial commit. Now let's save the file by performing a command C, say yes, hit enter, perform the git status command, and right here you'll see that there is nothing to commit and the working tree is clean. We performed our initial commit where we created 3 new files. the about.html file, index.html file, and the style.css file. You might wonder where a commit went, and you'll probably think that we can't recover anything of it. Well, Git has a command called git log, which shows you a record of all your commits. Right here, you'll find your commit history, but at the moment, we only have one that we just created called initial commit. Now, a commit always identifies itself by a name, which has been hashed by Git using the SHA-1 hashing method right here. Then we got parentheses saying head into master. And in most cases, this is the main integration branch, unless you specified not to. Head is a special type of reference that points to another reference. And right here, head has been pushed into master. The area we're working in right now is called head, where we have untracked files and so on. Now let's end it by saying Ctrl-Z. Let's perform a clear. And let me show you the second method on how you can commit files. First, we got to make sure that we add a new file. So let's say nano contact.html. Let's say contact form. Save the file. Perform a git add contact.html. Alright, the file has been added. Now let's perform git commit one more time, but don't hit enter right here, because we have the option to add a commit message right inside of our command. That can be done by adding the -m option of message. Then we have to add our message in either a set of single quotes or double quotes. I usually prefer to work with double quotes, so let's go with that. And right here, let's say initial commit with the -m flag. Let's hit enter. One file has been changed. If we perform the git log command right here, you'll see that we have two commits. We got our first one named initial commit, and the second one called initial commit with the -m flag, where we added our contact.html file, but our git commit and the message have been placed inside one command. Now there are a couple additional parameters that you could add to your git log command, and I do want to show them to you since they can be very useful. The first command will be the git log, and adding a parameter is very easy since we only need to add a double dash followed with the parameter name, and in our case right now we're going to use reverse. As the name implies, this will output the commits in a descending fashion, meaning that the oldest will be shown first. Right here, initial commit has been shown first. At the moment, we only have two commits. Imagine a complete list right here where you don't really want to see. And in most cases, you are actually in need of the most recent ones. There is a command which will limit the number of commits that are being shown, which is git log -n for number, followed with the number of commits that you want to show. Since we have two, let's just say one. And right here, our latest commit is shown, which is initial commit with the M flag. The next few parameters are used to show certain commits based on the dates. And I won't perform all of them, but I will show them right here, which is git log. And you show commits after a certain date by saying --since is equal to, let's say, 2022 10/2. You could also show commits after a certain date, where we just say --after is equal to 2022 10/2. We could also replace after with until, which will show all commits until a certain date. You could also show them before a certain date, but you could also replace the before and the date with the author parameter, which should be equal to a name of code with Dari. Right here, you'll see that both commits have an author of code with Dari. There's also a commit which will show you what files are added or changed, which is the git log --stat command. Right here, you'll see that in our initial commit, we added the about, index, and style file. And in our second commit, we only added the contact.html file. Finally, you could also show commits in a simple graph format by saying git log --graph. Now that we have dived into the history of our commits and the logs, it's time to dive a bit more in depth to see what changes have been made. If we perform the git log command one more time, you'll see that these hash names that we did talked about before, with those hashed values, you could easily see what snapshot has been made and what code has been implemented. This can be done by copying one. So let's say that we want to check the initial commit, perform the git show command followed with the hashed code. Keep in mind that you could either copy the hash code or you could add the first 7 characters. In most cases, you do need to perform a git log and copy the code anyways. Right here, you will find a detailed output of the commits that have been performed. At the top, you'll see the commit, the author, the date, and the message, followed with the differences inside the About page right here, where we added this green line right here. The second section is the index page right here, where I need to scroll down a little bit right here, where we added one line. This is my first Git file. Style.css file, we only added the character X. Keep in mind that whenever you delete a row, the plus sign will be a minus and the line color will be red. At the moment, we're checking the changes from a file we have already committed. But there is a command which will show you the difference between the last commit and the current working directory. And this is actually the most used command that I perform. If we perform a git status command, you'll see that we have nothing on our branch to commit or to check. So let's perform a nano index.html and let's add some new stuff right here. Right below our this is my first git file, let's add a h1 saying woohoo, close it off. Let's add a paragraph of paragraph. Now let's close it off. Now let's save our file. All right, perform the git status command. You'll see that one file has been modified rather than being added, called index.html. A tip that I could give you is that you always need to perform the git diff command before you perform the git add command of a certain file, which is a good habit to get used to because it makes you double check the files that you are trying to commit. So let's do that. So let's say that we want to perform the git diff command, which you can run without additional parameters, but it will check the difference from all files. The best possible way is to add the file name to it. So let's say that we want to check the differences from the index.html file. Right here, you'll see the same information as shown in the git log command, but it has only outputted one specific file. It's also telling us that 2 lines have been added, the h1 tag and the paragraph tag. Alright, so let me repeat myself one more time. You should always double check the file before you commit it, which is called a final review. So pretty much the following steps needs to be performed. We first perform a git status command, then we perform a git diff of the index.html file, which we have modified. You'll see 2 new changes, which we have added ourselves and we are satisfied with the changes. Now let's go back. Then we need to add the file by saying git add index.html. And finally, we need to make sure that we commit it. So git commit -m with a message of edited index.html file. Next to adding files, Git also allows you to remove files from your Git status. We could perform a simple rm/rf index.html to get rid of the file, but this isn't a Git command. This is a command that you perform from your local machine. If we hit enter, perform the git status command, you'll see that we have one change because we have deleted the index.html file from our working directory, but it still exists inside our staging area. Now there is a command that will show you the different files inside the staging area, which is git list all files ls-files. Even though we removed our index.html file, you'll see that it is still available inside our Git files. Every time you want to stage changes, so basically add, modify, or delete files, we have to add the file, even though it is deleted. This might not make sense right now, because why would you add a deleted file? Well, once again, we need to stage the changes. So let's perform a git add index.html, hit enter, let me perform a clear, say git ls-files, and you'll see that the index.html file has been removed. If we run git status, you'll see that it has been changed to green, meaning that it has been staged. So let's commit it. So let's say git commit m, let's say deleted unused file. And that's it. Whenever you want to delete a file, you have to delete it from your working directory as well as your staging area. Now these are 2 steps that could actually be done in one line. So let me show you how this can be done a lot easier. What we can say is git rm contact.html. Keep in mind that just like adding, you could add multiple file names right here. So we could also say contact.html. Or you could even remove contact.html and about.html and add an asterisk .html, which will remove all files with a .html file extension. Let's undo it and let's remove our about.html file, perform a git status. You'll see that it has been deleted. So let's say git commit m named deleted unused file. Maybe you've made changes in a file which you don't want to completely delete, but you just want to reset them. Git offers a technique which allows you to reset to the head. Now let me actually repeat myself one more time. The head is the latest commit of a branch. Git offers two options when you want to reset files. You could either hard reset a file or soft reset. We're going to start off using the hard reset method. And whenever you want to reset in Git, you need to perform the git reset command. We're not done yet, because we do need to add a flag, so -- named hard. Now the hard flag is used whenever you want to hard reset files of the staging area and the working directory. We're not done yet, since we do need to specify where we want to reset the file to. In our case, we're going to reset it to head. Before we hit enter, I do want to show you a couple additional options that you could add right here. If we perform the command right now, we're going to reset back to head. But we could also add a caret right here, which will reset the files to the commit before the head. Or we could replace it with a tilde, which is exactly the same as the command with a caret. Now you might wonder why you should use it. Well, it becomes more powerful whenever you replace it with a 2 or 3 or even a higher number. We're basically going back 3 commits right here before the head. If we replace it with 4, we're going back 4 commits before the head. Right now, we're simply going to reset it to head. If we hit enter, you'll see that it has returned a message saying that the head is now at the commit C832C59, deleted unused file. Now if we perform the git log command one more time, you'll see that we went back to the latest commit, which is the deleted unused file commit. Now soft deletes work pretty much in the same way, which allows you to soft reset files to head on Git. The command is also pretty much the same, where we need to add the git reset command, but instead of adding the -- hard flag, we're going to add the soft flag. We also need to specify where we want to reset it to. Now in our case, let's say head. And keep in mind that you could also add the same options with a caret and tilde to the head branch, which I won't cover again. We've talked about the topics that you need to know, such as repositories, adding, ignoring, committing, and logging files. But Git can be way more in depth, and since it is a beginner's friendly crash course, I don't want to push it too far. But commits could be a bit more complex than we have done so far, and I want to take it a step further to talk about it. When it comes to committing, there are 3 different states that a file can have. The first one is modified, where you have made changes to a specific file. The second stage is called staged, where a file has been changed and is being prepared to be snapshotted. The third stage is called committed, where a snapshot has been made of the entire working directory with the new files inside of it. Now Git allows you to navigate between different snapshots, and this can be done with the git checkout command. This command will change the files on the working directory, but keep in mind that you can't perform a git checkout command if you have unstaged files, because Git doesn't track their states yet. We can't just perform the git checkout command and expect it to pop up with a different snapshot. So before we can perform it, we do need to perform a git log command and copy the hashed commit code. So let's say that we want to go back to deleted unused file, copy the commit code, perform the git checkout command, and paste what we just copied. And it outputted a lot of text right here, but it is saying that we have switched to our git commit right here. We're not on master anymore, but we're located on a commit. Whenever you want to return to the working directory we're working in, we need to check out to the only branch that we've got. By default, the one branch is called master. If you're not sure about it, you could perform the git branch command, which will show you all available branches. At the moment, we got head, which is detached at our commit, and we have master. So what we could do is go back, and before we check out the master, there are two questions that you got to ask yourself. Is my present clean, so the master branch? If it is, you can continue on. The second question that you got to ask yourself is, have I made changes in the past? It is recommended not to do so unless you are an advanced Git user. If you have passed both checks, you could perform the git checkout, followed with the branch name, which is master. And right here, we're located right inside of our master branch again. We've made a couple commits already, but there will definitely be a time where you made a mistake or just want to undo a commit. Git offers a very simple command named git revert. There is a debate on whether you should delete a file and move on or perform the git revert command. I'll always recommend you to perform the git revert command over deleting a file because Git follows the time traveling rule. Never change the past. What git revert does is creating a new commit that contains the exact opposite of the commit you are trying to undo. We do need to have our commit name first, so let's perform the git log command. Let's say that we want to go to our deleted unused file. Then we can add a git revert and paste what we just copied. And right here, it's opening the same screen as before where you see information about the commit. And before we actually continue on, you always need to make sure that you're working on a clean working directory if you are trying to revert a commit. Now let's save the file, perform a git log, and right here you'll see that we have reverted the deleted unused files, which is coming from the commit message that you can see right here. Now keep in mind that a copy has been made. You don't always want to revert an entire commit. Git offers you the option to modify a single commit. This is very useful whenever you forget to stage a file or you want to change the commit message. Personally, I don't recommend modifying a lot of changes, but mostly use it for small changes or single files. Whenever you want to modify a commit, you have to perform the git commit command, but you have to add a parameter, --amend. What this parameter does is amending a commit in the staged area and it will make a new commit with it. If we hit enter, you'll see that the same screen will open again where you can modify your commit. Let's change up the commit message to new deleted unused files. Let's save it. If we perform a git log again, you'll see that our commit message has been replaced with new deleted unused file. Amending a commit takes everything in the staged area and makes a new commit with it. So let's do it one more time by adding a new file to it. So let's close it off. Let's say nano amend.html. Let's add a simple string right here of amend, save it. Now in order to add it to the latest amend, we could simply add our file to our commit. So let's say git add amend.html. Then we should say git commit --amend. Now keep in mind that you could even add an additional parameter right here of --no--edit, which allows you to make an amendment to the commit without changing the commit message. If you do want to change the message, you could simply remove the no edit, hit enter. Let's replace new with updated, save the file, perform a git log, and right here you'll see that our delete message has been updated and our amend.html file has been added to it. This can be checked by saying git ls-files, where you will find the amend.html file. Before we wrap up the chapter of commits, I do want to talk a little bit more about commit messages, since these are one of the most important aspects when it comes to version control. The message that you add to your commit are not only for you, since most of the time you will be working with multiple developers on a single project. The commit message should tell other developers what changes were made in the commit and why those changes are made. Whenever you're working on a specific issue, other issues might come along and you will be committing it in one single message, which should not be done. Once this happens, you should split the issue you're working on into multiple issues, rather than adding it in one commit. Each commit that you make should stand by itself. You should never commit a project that isn't done. Keep in mind that you also shouldn't pass in too much information in a single commit. It must be concise and straight to the point. There's no need to add every single name or functionality inside a commit message, since other developers can simply use the git show command to see which files are changed. I will add a couple important tips and tricks when it comes to commit messages, which I recommend you to follow whenever you make a new commit. Whenever you add your commit message, you should keep in mind that it shouldn't be longer than 50 characters. Whenever you search for commits through the git log command, you'll see that a commit message won't be formed on a new line if they are too long. Now the second one is pretty obvious, where you should start your commit message with a capital. You should not add a commit message with a period. You should write your commit messages in the present time. Keep your commit messages consistent and don't add too many details. Now it's time to talk about a very important topic, which is ignoring files. My channel is based around Laravel, and within Laravel projects, you have certain files that you don't want to push to Git. Think about a .env file, where environment variables that are expected to be different in each environment are stored and should not be committed. Or the vendor directory, where Composer installs its dependencies. The files that should not be committed need to be listed inside a hidden file named gitignore. Keep in mind that the gitignore file is a global meaning that it should be placed at the root of your repository. You can't place it inside a subdirectory, because you will only exclude files that are located in the same directory, so pretty much the subdirectory. With that said, you can also have multiple gitignore files. Let's say that you have one inside your root, but inside your root you have a controllers directory, where you want to exclude certain controllers. This can be done right inside of the gitignore file in your controllers directory. Now the order matters, since you need to create the .ignore file first and then the .env file. So let's say nano.gitignore, and right here you simply have to add the file or folder name that you want to exclude from committing. So let's say .env, and let's say on the line below test.html. Alright, let's save it. Let's go back, and right here, let's say nano.env. And for the sake of this example, we're going to add one key value pair right here. So let's say app_URL is equal to git-in-cli.test. Save it. Let's also create the test.html page by saying nano test.html. Let's say test page. Save it. And if we perform the git status command right here, you'll see that it isn't visible inside the git status command because we explicitly said inside our gitignore file that the .env file and the test.html file shouldn't be tracked, but the gitignore file is. Now let's commit the gitignore file by saying git add.gitignore. Don't forget to commit by saying git commit m named add.gitignore to hide files. We've talked about branches a little bit, but it's time to dive into it a bit more. A branch in Git allows developers to diverge from the production version to different versions. Most of the times, you create a new branch for every single functionality of bugs that needs to be fixed. By doing that, you will isolate your code changes. You don't want to commit everything directly to the master branch. You want to create different branches which you will eventually merge into the master branch. There are multiple ways on how you could create a new branch, so let's start off with the first one. Whenever you want to create a new branch, you need to perform the git branch command. You do need to add another option right here, which is the branch name. So let's say that we're going to build a new feature /login page. Now the branch name needs to refer to the functionality you might be building. If we hit enter, you'll see that we haven't changed branches to the newly created branch. But if we perform the git branch command, you'll see that we did create the feature /login branch. Now Git uses an asterisk, as you could see right here, in front of the master branch. And it also has a green color. Both of these are used to identify the active branch, which represents the head pointer. Now, whenever you want to change your branch, you simply need to perform the git checkout command, followed with the branch name. So let's say feature /login page. If we hit enter, you'll see that our branch has been changed to feature/login page. Now this took a while, and there are a couple steps that can be done a lot easier. Let's perform the git checkout command one more time, and we're going to add a -b flag right here, which will automatically change our branch to the one we're creating. So let's say that we want to create a new branch called feature/register page. Right here, you'll see that we created a branch and we changed the branches to the register page branch. You could also create a branch from another branch, which works in the same exact way. We first got to say git checkout b. We need to add a new branch name, so let's say feature/cart. And then we have to define the branch we want to create our branch from. So let's say feature/login page. Right here, we created a new branch called feature/cart from the login page branch. This was it for this video where we dived into Git in CLI for beginners. If you do like my content and you want to see more, leave this video a thumbs up. And if you're new to this channel, please hit that subscribe button.